In this lesson, we will build an intuitive picture of different types of enthalpy changes. We will see what each name means, what it looks like, and how to remember them. First, the standard enthalpy of formation. This is the enthalpy change when 1 mole of a compound forms from its elements in their standard states at 1 bar and 25 degrees Celsius. For example, carbon as graphite plus oxygen gas makes carbon dioxide gas. This particular reaction is exothermic. Delta H of formation equals negative 393.5 kilojoules per mole. Next, enthalpy of reaction. Delta H are Xn for any specified balanced chemical equation. The formula says delta H of reaction equals the sum over products of delta H of formation minus the sum over reactants of delta H of formation. This works for combustion, synthesis, decomposition, and more. Third, standard enthalpy of combustion. This is the enthalpy change when 1 mole of a substance burns completely in oxygen under standard conditions. A classic example is methane combustion. Methane plus 2 oxygen gives carbon dioxide plus 2 liquid water. Combustion is strongly exothermic, here about negative 890.4 kilojoules per mole. Fourth, enthalpy of neutralization. This is the enthalpy change when an acid and a base react to form 1 mole of water, usually in dilute aqueous solution. For a strong acid with a strong base, the typical value is about negative 57 kilojoules per mole. Fifth, enthalpy of fusion. This is the enthalpy change when 1 mole of a solid melts to a liquid at its melting point. For water, ice becomes liquid water. It is endothermic. Delta H of fusion equals positive 6.01 kilojoules per mole. Sixth, enthalpy of vaporization. This is the enthalpy change when 1 mole of a liquid vaporizes to gas at its boiling point. For water, liquid becomes vapor. This is also endothermic. Delta H of vaporization equals positive 40.7 kilojoules per mole. Seventh, enthalpy of solution. This is the enthalpy change when 1 mole of a solute dissolves to form an infinitely dilute solution. It can be endothermic or exothermic depending on solute-solvent interactions. For example, potassium nitrate dissolving in water is endothermic at plus 34.9 kilojoules per mole. How to remember? Formation is from elements. Combustion is burning in oxygen. Fusion and vaporization are phase changes. Neutralization is acid plus base makes water. Solution is dissolving. All of these are specific cases of delta H of reaction, and they all obey Hess's law. A final picture for Hess's law. If a reaction goes from A to B with delta H1 and from B to C with delta H2, then the overall from A to C has delta H equal to delta H1 plus delta H2. Energies add when you add equations. The big idea. The name tells you the situation, the sign of delta H tells you endothermic or exothermic, and Hess's law lets you add steps to find unknown enthalpies. Practice by classifying a few reactions and sketching a quick energy arrow each time.